welcome to today LeetCode challenge. And for today problem, we need to work with the problem distribute coins in binary tree. And for this problem, we are required to return the minimum number of moves to make every node in the binary tree have exactly one coin. And in this problem, we are given two examples. For the first example, we have 3 coins in the parent node, and then we will need to distribute the coins to the children. In here, because we need to satisfy the condition, each node have exactly one coin. So in here, it means that the parent need to keep one coin, and then he will distribute one coin to the left and another coin to the right child node. And eventually, like in here, we need like 1 path and 2 paths. So it means that we need the minimum number of moves is like 1 plus 1, that equal to 2. So yeah, so this problem is quite easy, and it just gives us intuition about how the problem is and how is the algorithm works. But I believe that in the second example, it will give us better understanding, or maybe some of the special maybe conditions for us to solve this problem effectively. So in here we have like 3 coins in the left child node, and in here we will distribute 1 coin to the parent and another coin to his sibling, or like in the right child node in here, that is 1, right? However, this is not like the first example. Like in here we have the result 2, but in here we have the result 3. So what happens? So in here, if, for example, if we send 2 coins at once to the parent, and then we will give another coin to the right child node, right? So because if we give 2 in here, and then we will give 1 in here, so it means that eventually we only have maybe 2 moves, right? Number of the moves, right? We move 2 coins in here and 1 coin is in here, 2 moves, right? But algorithm is not in this way. It works in different way. So how does this work? So it means that in here, this left child node, he creates 2 paths. The first one is he move 1 coin by this path to his parent, and move another coin by this path to his sibling, to the child node, to the right child node in here. I mean the right child node in here. I consider this one is a parent, right? So in here, we move 1 in here and 1 in here. So eventually we have 1 plus 1 and plus 1. We have 3, right? So this observation is very important. Okay, so another observation before we jump into this observation, and then we will talking about another observation. So we need a way to traverse through the tree. In here we have binary tree, of course, and so in here we need to intuitively we need information from left child node and the right child node, and then we will consider the parent for the final result. For example, if this one feedback to here that I need score, and then we will use the parents to give back the coin or redistribute the coin in the tree. So in here, it means that we need to visit the children before the root node. So it means that we can use some kind of the post order traverse. Okay. So for now, because for any tree, we need to come up with the problem of the we need to find the recurrent relation, and also we need to find the base case for this. And then for this, we just redraw it, and then in here we have 0, and in here we also have 0. Of course, in here this one, this will go to none, and this one is none, and this is none as well. And so it means that in here, whenever we reach the none node, so it means that we don't need to give any coins to this node, and then this also it will be our base case, so it will return the 0 for our for the parents, and in here it will give us give the parent 0, right? And so because this one is the 0, so it need to have 1 coin in here, so it means that somehow it need to feedback to the parent is that I need 1 coin. Or for example, for now I define that if we need 1 coin, and then it means that the return value would be -1, right? So for now we come up with the base case. This is the base case when we reach the none node, and then we need to recurrent relation, how can we return the value to the parents. So in here, we could consider this one is the subtree. So let's say Yeah, so it means that in here the return value would be like the left try node value, right try node value, and because we want to keep one here, so it means that we need to consider what is the value in here, and we only need to keep one quite in here, so it means that we need to minus one. So the recurrent relation would be like the root of r plus left plus right, and then minus one, because each node we need only one quite. Okay, so because like in these two cases, and then the yeah, to come up with the problem is not obvious, so I have another tree, and then I hope that using this tree you can see the relation, and then you can, yeah, make the problem become easier. So in here, like let's say we have 0 in here, and this we will have 4, and this one we have the 0, for example. This is 1, and this is 2, for example, and this one is 0, and this one is 0. Okay. So for now we have the recurrent relation, right? And in here I will use the post order traverse, and in here I will reach to the base k of the none, and then I will feedback with the value of 0. So in here, like, it will apply the recurrent relation, and it means that in here I will return the value of 3. I keep the one in here, and then I just return the value of 3. Okay, so post order traverse. So we will come here, come here, come here, and then this one will feedback the -1. This one will feedback with the -1. So in here, the feedback with the -2. This one will feedback with the 1, and eventually this one will feedback with the -2, and this one will, yeah, totally, yeah, base case that is 0. So you can see that this is like, it will tell us that, yeah, eventually summarization of all the feedback will be 0. Yeah. So in here we have an intuition in here is that, yeah. So what are this value meaning? What is this value meaning? Okay. So this value means that in here we need 1, and we can give away three coins. And then if you notice in here, for every coin, like every coins we have, it means that for every coin we can give away, and then we create the separated part for it, right? So it means that in here I can create 3 separated parts for 3 coins I have. Okay. So how about this one? Yeah, it means that this one is a giveaway. We can give away 3 coins. And in here, like, we need to have 3 coins. Sorry, 2 coins. 2 coins to go to this node, right? To satisfy the problem. And because we are finding the minimum number, so you can see that 1 coin in here is to address 1 problem in here or in here, right? So yeah, it doesn't matter. Because if we have 1 coin in here, we feed back to the parent, and then it may resolve the problem first. Because if he use it, and then he will not give it to the children. Okay, and yeah, so because like we solve the problem in the subtree, so we always get the minimum, right? Okay, so in here, like, because like in here we need to have 2 coins, right? So it means that we need to have 2 paths to come to our node, right? And in here, like, I need 1, and I need 1. So in here, I give away 1. Okay. So if we forget about the direction, if we forget about the direction, if we ignore the direction, so you can see that in here we don't care what is the direction, but it means that the minimum number of moves, that is equal exactly to the number of the paths, or number of the paths we have. In here I can give away 3 coins, right? I just give it away, right? Because we don't want to repeat the path. So that is the reason why we create 3 paths, and with these 3 paths we have a minimum number of moves. In here, like, we have 3 paths, right? In here I require 2 paths, right? In here as well, in here is 1, and 1. So you can see that in here, like, we just need to sum all of the paths we have in the tree, and then we can come up with the solution. Okay, so let me check this. So this one we have 3, right? And in here, so in here we have, because we need the number of the paths, so that is the reason why in here, with the feedback value of 2, we can get the absolute value of -2, right? So in here we can have the absolute value of 2, sorry, -2. And in here, we also have absolute value -2. In here we have 1, right? In here we have absolute of -1, and also okay, so this one is like 3 plus 2 plus 2 plus 1 plus 1 and plus 1. So the problem become more easier, and then we just need to summarize all the parts we have, right? So indeed this intuition make the problem become more easier because we don't need to like consider all cases where this node contain the negative value, this node contain the positive value, positive and positive. We need to consider 4 cases, right? But this one, like with just the intuition, we can simplify the problem. So in here, it's like 3. Okay, so in here, like 3, 3, we have 10. Okay, this is the result. So let's check with our problem in here. Okay, so like in here, we have 0, right? In here, we have 3. And in here we have 0. So it means that this one will fit back like with the value of 1, right? So it means that this part is like absolute value of -1 is 1, and we write down 1 here. And this one is like 2, right? We feed back with the 2, we feed back with the 1. So in here, this node will require 3 parts, right? So yeah, so that is exactly the value in here. Okay, so let's make the code on the lead code first. Okay, so in here, I will use the DFS, and then we will have root, and we have min moves, right? And for the min moves, like we define the base case. For the base case, like we will do the things like oh yeah, in here I use Python, so we will return the value of 0, and for the we will call the first order traverse, right? And then we will call the left turn from the left, which will be the DFS of fruit.left, and we need to give the min moves. Min moves is just my variable to summarize all the parts we have. And then in here, the DFS of fruit.right, and we'll give the min moves, and then we define the min moves, which will be, I will define this one is an array because I did okay. Okay, so it is not good solution, right? So let's pass the it. Okay, it seems to be better. Okay. Yeah, so I hope that this video is helpful for you to prepare for like coding interview, or useful for you to code. And yes, so thank you for watching my videos. And yeah, if you can, please give me a like or subscribe. Yeah, thank you so much.